Hi, my name is Daniel Manuel, and this is Lab 3. Introduction. In this lab, we will measure the distance dependence of the magnetic field due to a small bar magnet, and compare the distance dependence predicted by the on and off axis magnetic fields derived from the PHYS law. The value for n that was calculated was negative 0.7397. The value for the predicted perpendicular magnetic field was 6.36 times 10 to the negative 5 Tesla, and then the model predicted 6.12 times 10 to the negative 5 Teslas. Here are some fundamental principles and assumptions and formulas. Distance dependence of the magnetic field of a bar magnet, measuring the off-axis magnetic field, and the formula that we'll be using for the data analysis. Procedure. To begin with, we had to compensate for magnetic north. To do this, we had to place the phone onto the table and rotate until the exponent of the magnetic field is as close to 0 as possible. Next, we had to find the magnetometer chip in the phone. Then, we moved the phone at various distances across the meter stick. The magnitude of the magnetic field due to a bar magnet falls off with the distance represented by the following equation. And then we had to find a distance from the magnet so the sensor produces a magnetic field with an x component of 20 microtesla, and then do the same for 70, 120, 170, and 220 microteslas. Analysis. Here we have a table and the corresponding graph of the natural log of magnetic field versus the natural log of the distance. The distances in the table were obtained by moving the phone across the meter stick and observing where the magnetic field is equal to 20 microtesla. Thus, we have R20. The same was done for each of the distances and recorded, averaged, and then used to calculate the magnetic field for each set. Those averaged distances and magnetic fields were taken the natural log of to be linearized. With this linearized plot, we can determine the value of k, which is obtained by taking e to the power of the natural log of k. And we got the value of 3.363 times 10 to the negative 5. N can also be obtained, and it is the slope of the graph, which is negative 0.7397. Glow script code. This slide contains the code that was used in the final model output that was compared to by the value that was actually obtained from the experiment. Lines 56 through 61 define observation locations that are on axis and perpendicular to the axis. 56 and 57 are on axis, and 58 through 61 are perpendicular. Lines 67 through 99 calculate the magnetic field on axis and perpendicular, and then create an arrow for that magnetic field. 67 through 75 are on axis, while 81 through 99 are all perpendicular to the axis. What if? What if you hadn't orientated your experiment to compensate for the magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? All of the data from the phone would be skewed in the direction of Earth's magnetic north if that were to happen. What if you were to stick two identical magnets together, end to end, and then run the experiment again? The magnetic field magnitude would double, but the direction would remain the same. Some possible error may come from the calibration step in the beginning of the lab. Thank you.